Hello and welcome. Today I want to talk about how to create a sub-program callout from a standard program in an Okuma CNC. In this case it's a .SSB file extension, and it's easy enough to do. All you need to do is in your IGF program, which is normally stored, I think their ADO, the file directory, is where they're normally stored. If you're running a IGF program, then you just create an NC block, and in that NC block you would just have the simple function which I have written down here, call. It's a call function with an O letter, and that O letter is followed by 4 letters. Doesn't matter what they are within reason. The first 2 must be letters, the last 2 can be either letters or numbers. So yeah, you can put that into a IGF program or as an NC block, as I was saying, or if you're in the MD1 directory and you're running an advanced a .min program, then yeah, you just do a simple call line, just call function like this. So how does it work? This call function then goes to the MD1 file directory, looks for any .SSB file extensions like this one here. Doesn't matter what the file extension name is called, it'll open it itself, search through it, and as soon as it finds a matching code like this, it then runs it. As soon as it hits the RTS, it will go back to where it was and then finish the program. Okay, so in this case it would run this program, call to engrave, find this file here which contains the callout it's looking for, run whatever code is between there and the RTS, and RTS and end. So very basically, your .SSB file needs to have the name of the macro you're calling and must finish with RTS. Other than that, whatever's in the middle, it will run as you would any .min program. So why would you do this? What's the main benefits of doing these kind of programs? Well, the main benefit is you can create one .SSB file that will work on every program you do, or some, and you can change them by putting in parameters or variables. So how do variables work? Okay, so your machine has common variables. I'll just pull this down. Common variables, most lathes are V parameters. I think mills are VC. So if you go to the parameters page on your machine, display page 1, you normally have anywhere from 1 to 200 parameters. You can pay more and get up to, I think it's 1,000 from memory. So if you wanted to, you could, in here, you could say something as simple as variable 1 is equal to 1. So when it runs the code, it sets this parameter. Now these are not these are global, they're not local. So what I mean by that is, once you set it here, you can, when you turn off the machine, turn on the machine, they're still set. You can look at it from a main program, you can look at it from a .SSB file, you can look at it from anywhere. So they're very handy. So we'll talk about local ones in a few minutes, but for now we'll just talk about global. So if you set this global variable 1 equals 1, it runs this call O engrave macro, finds it here, runs it. So here you can have some sort of query where you can actually query that common variable if you wanted to. So you can do if square bracket variable 1 is equal to 1, then do something. So normally you have an n line, and we'll say n GOTO, right? And here I'll put in, this will make sense in a second, so just bear with me, n GOTO. Here I'll put in error. Alright, so now we've set it, variable 1 is equal to 1, run this macro, jumps down here, variable 1 is equal to 1, n GOTO, jumps from here straight down to here. Okay, then it will come down here, it will wait 1 second, and then RTS, finishes the macro, back up. Now look, this doesn't do anything. This is just to show you how the macro process works. You could then set this to 2. So now what will happen is sets 2, runs the macro, jumps all the way down here. Oh, there's the macro. Variable 1 is equal to 1. No, it's not. Comes down here, errors. Machine stops. It'll put up an error because it won't recognize what error means and alarms out. Okay. So that's a global variable. There is ways then of putting in local parameters, variables. So you could put in stuff like text equals 5. Alright, I'll just delete this. Alright, so now it's the same kind of thing. We can just change this variable 1 to be text. Okay, so now you're calling this macro and sending this data with it. So you're calling it, comes up here. We go if text is equal to 1, go here. Well, it's not, it's equal to 5, so it's going to error. Alright, so that's the basics. Now this here, we've called this text, right? And it will be active in here. However, you reset the machine, that's gone. It doesn't know what text means anymore. So you need, that's the benefit of this. In a way, you're not tying up common variables. It's fast. It's a better way of doing it. It's neater. It doesn't hog as much machine resources. All right, so let's have a look at a more complex version of all this. All right, so this is an engraving macro. This macro engraves around the outside of a part, and we use it for engraving sequentially increasing numbers from parts. Okay, I'll talk you through how it works a little bit. All right, so call OEngrave. It will find this file here, and it sources this. This is what it's looking for, call OEngrave. It won't run this, even though this is this file and everything in here is in the file. Even though it says call OEngrave here, it's not going to run that code because it's not the, it's prefixed with call. So I use this as a means of copying all this, Control C, and then pasting it into whatever program I want to use it in. Sometimes I put it in brackets just to be safe. In this case now what it's doing is it's sending these local variables. The text height is equal to 5. I'm engraving on a diameter of this. Z position is here. I'm starting at C position here. Number of teeth on my end mill is this. 800 RPM. My plunging feed rate is 50. We're in millimeters per minute, by the way, not inches. Sorry. The depth of cut of the engraving. The feed rate per toot of the engraving, and the tool we're going to engrave on. And I'll go through this piece in a minute to show you how this works. And this is percentage, which I normally set as 1. This is the spacing between each letter as we go around the part. Okay, here we set the engraving number, the ID number, to common parameter variable number 1. And if you're starting on your first part, we set variable 2 to 1. And then as you go on to the second part, the machine automatically increases for each one. So we get, as I said, individually unique identifying numbers for each of them. Okay, so it comes here, it runs it straight away, just to give me some sort of accountability on where the program's at, what variables are set to what, where, you know, I do set it to common variables. However, you can just get rid of it if you wanted to. For example here, if variable 29, well here we're setting tool. So whatever we sent across as being the tool number, in this case number 9, up here is what we originally sent, but it's the same thing. So whatever we had in our program as being the tool number, in this case number 9, then when we get to here, we could literally, instead of variable 29, you could put in tool here. And all the way along down here, good thing about Word, you can go Control F, find variable and replace with all or whatever, but we're not going to go down that route. So if the tool number is equal to 9, so it's not equal to 1, so it continues. So this is how these work, in case you didn't catch it last time. If it's equal to whatever's in these brackets, so in this case, if 9 is equal to 1, do this, else continue. If the tool number, which in this case is 9, is equal to 2, so it'll just keep going down till it gets to here, which is 9. And then it says, oh, okay, go to NTOL9. So it skips all this and then jumps all the way down till it finds it. In this case, it finds it here, right there. So now it runs this, which is setting the tool number to being tool 9 on an Okuma. When it's finished, it uses the GOTO function. So that's easy. It's literally just a GOTO, an N number, and then 4 digits, letters afterwards. So it'll go to N spin. So again, there we go. Don't have to go too far. There is N spin. So then we're down here and we're like set the .SSB to the RPM. Easy enough. So you can see how you can quickly make a program that is very flexible. You can put in X positions, and so you can like program a facing cycle, starting at X diameter, which is a variable, and yeah, amount of stock is a variable. There's so many things you can do with this. It's actually just unlimited. It is limited. It's limited to your imagination. So look, I hope I've given you some sort of insight into what's capable on these machines, how to do it. If you have any questions, or you'd like to see a video on any topic that I have briefly covered in this little video, please let me know. Please like and subscribe to see more of the same as soon as they appear. And yeah, as I said, any comments, please leave it in the video comments down below. Thank you, guys.